So let's say this is the object here. This is the object here. You want to raise this object to a certain level, right? This object. But if you use a hand to pull this object, this man here, if he just use his hand to pull the rope here and hope to raise the object up to the platform, not possible because it is too heavy for the person to lift it. So how can this person lift up this heavy object, which is heavier than the man himself? So he can try to add weight to the other side. There is a platform on the other side, and the man will add the weight one by one until a certain time when the mass over this side, the weight on this side is more than the other side, and this thing will start to move up. So he can raise up by gradually increasing the load on the other side. And when it is greater than the weight that you want to pull up, the thing will move up. But this one is, how to say, this way of doing it is not efficient at all. You know why? Because this man has to carry many weight and drop it downstairs. Then once the thing drop downstairs, you cannot lift anymore. You have to collect all this weight that has piled up here, carry using your hand, then move up again. It's not efficient at all, right? It's just that you break down the heavy weight into smaller weight only. That's all. This is not efficient. Now, the more efficient method will be you use several pulleys. So this pulley will actually lighten the job, lighten your job. So if you have several pulleys like this, you can actually pull up the box. Okay, so have several pulleys is more efficient. Okay. The answer given in the book is this one. Right? Attach one end of the cable to the object to be lifted. So attach the cable to the object. The other end to a platform. So the other end you attach to a platform here. Place lighter weight on the platform. So this man is going to place the weight on the platform until the total mass of the weight, until the total here, exceed the mass of the heavy object. So when the total here exceed the mass of the object, this object will raise up. But this is not efficient because although your object has moved up, all these cubes here maybe can be bricks or what, they are all down there. You have to move the bricks up again to, lift up another load, which is very inefficient. So the better way will to use a multiple pulley. If you use the multiple pulley, then you can use less force to pull up a bigger weight. You read this question, exercise 4.13. You read this 4.13. This one, read this one. Suppose
Suppose in the same Atwood setup, another string is attached to the bottom of M1 and a constant force F is applied, retarding the upward motion of M1. If M1 equal 5 kg and M2 equal 10 kg, what value of F will reduce the acceleration of the system by 50%?
Okay. We have two objects here. One is 5 kg, the other one is 10 kg. Okay, so as a result, the system will accelerate clockwise because this side is heavier. My right side is heavier. So the system will rotate clockwise. And how much is the acceleration rotating clockwise? So I have to calculate. To calculate the acceleration, I have to look at the system as a whole. I have to look at the system as a whole. So I try to find out the net force. The net force is the bigger one, 10G. 10 is the mass, 10 is the kilogram, the mass in kilogram. G is acceleration due to gravity. So the weight is 10G. So I use 10G minus 5G. So the net force is 10G minus 5G. How much is the net force? The MA. The net force is MA. But the M here, because we are looking at the system as a whole, right? The M here is 5 plus 10. It's the whole system. This is the 5 kg. This is the 10 kg. So if we look at the system as the whole, the mass is 15 kg. So 15A is 10G minus 5G. So how much is the A? A is 5G over 15. So this will be the acceleration of the system when there is no obstruction. When there is no obstruction. Okay, so you bear in mind this one, 5G or 5 or 15G. What is the question asking about? The question say, what value of F will reduce the acceleration of the system by 50%? Okay, right. So we know that now, is this the one? Never mind. We know now that this whole system is accelerating clockwise with an acceleration of 5G over 15, right? 5G over 15, right? This is the acceleration of the system. Now they want to have a force that will retard the system by 50%. So actually they want to have a force on this side. On this side, the size of the force is F. The size of the force is F. The size of the force is F. And when you add this F on the left-hand side, it will cause this acceleration to reduce by 50%. So let me calculate what is 50% of this. 50% of this 5 or 15G is here. 50% 5 over 15G is actually 5G over 30. Right? 5G over 30. Now we form a new equation. What is the net force? Right? The net force is 10G minus the 5G and minus this retarding force F. Oh, it's over here, right? The net force is the 10G minus 5G minus the F. They introduce a new force there called F. So I try to find out what is this F from the equation. I try to find out what is F from the equation. What is F from the equation? This M is actually 15 because we are looking at the system as a whole. So this M is actually 15. This M here is actually 15. Then the A now become 5G over 30. We have found out the G earlier, 5G over 30. So the others, 10G is 10G, 5G is still 5G. So I'll make F the subject of the formula. So move the F over to the left hand side, 10G minus 5G, and this whole thing here is 2.5G. So substituting the value of G with 9.8, you find that the retarding force is 24.5